Hello students, this is Professor Lester. Today we're going to be talking about Notes 2-2, Solving Linear Systems by Substitution Method. Please get out your notes packet and something to write with, and here we go. The substitution method functions by substituting a solved variable from one equation into the other equation. There are some steps we need to follow when using the substitution method. The first step says we need to isolate a variable in one of the two equations, or get a variable by itself. Step 2 says we're going to take the expression that is equal to the solved variable and substitute it into the other equation. Note that when you complete this step, you should only have one variable. It can repeat, but it should be the same letter throughout the equation. Step number 3, you're going to solve for the variable. And step number 4 says that once you have found a solution for one variable, substitute that value back into one of the original equations and solve for the other variable. When we get finished with this, we should have a value for both variables that we will put into an ordered pair, which represents the location or the point at which our two equations intersect each other. Example number 1. We have 2y equals x plus 7 and x equals y minus 4. The first step says that we need to look to see if one of the variables is isolated. You see here that you have a 2 with the y, so the y on the first equation is not, and you have a plus 7 with the x. But if you look at the second equation, you see that this x is all by itself, or what we call isolated. Therefore, we are going to take this expression that is equal to x, and we're going to substitute it in for x. So we will take the top equation, which is 2y equals, but instead of putting x plus 7, we're going to put y minus 4 plus 7, so that we have now substituted the expression y minus 4 in for x. That is step 2. And you'll notice at this step we only have the variable y. We do not have any more x's. So now we can solve for y. When we solve for y, we first look to see if there's the distributive property. You'll notice there's nothing in front of the parentheses here, so we will just write 2y equals y minus 4 plus 7. Then the next step says that we need to combine like terms. We have a negative 4 plus 7, so negative 4 plus 7 will give us a positive 3. Then just bring down this y and bring down this 2y. The next step says that we need to get all the variables on the same side. Well, you see on the left hand side we have a 2y, and on the right we have a y. Well, we can put a 1 in front of that y, and we see positive 1y, so we will subtract 1y, so they will cancel out, and move that y over here. So then we get 2 minus 1y equals 1y, and we will bring down this 3. So we get 1y equals 3. Then we could divide by 1, and we would get y equals 3. So now we have completed step 3, which says that we will solve for one of the variables. The last step says that we need to substitute y equals 3 into either this original 2y equals x plus 7 or into x equals y minus 4. It would be easier for us to use the x equals y minus 4 and substitute 3 in for this y, so that we would have x equals 3 minus 4, because we found that y is equal to 3, so we can substitute that 3 in. And then we can solve, and we can say x equals, and 3 minus 4 is a negative 1. So we have found that x equals -1 and y equals 3, but you must always remember to put your answer into a ordered pair, which in this case we found that our ordered pair is a -1, 3, and that represents the point at which our two original equations will intersect each other, giving us the solution to this system. Alright, example number 2. We have a -3x minus 4y equals a -2, and y plus 5 equals 2x. Now if we look at the first equation, we can see that we have a -3x and a minus 4y, so neither the x or the y are isolated. If you look at the second, you see that you have a plus 5 with the y, and you have a 2 with the x. So that one is not isolated. So we need to isolate one of the two equations. The second equation is easier because all we have to do is subtract 5 from the left and move it over here to the right. Those 5's will cancel, leaving us with y equals 2x minus 5. So now we have completed the first step where we have isolated the y, giving us the expression 2x minus 5. We can now plug or substitute in this expression into y for the first equation, which will result in a 3 or -3x, minus 4, but instead of putting the y there, we're going to put in 2x minus 5 because that is the expression that we have equal to y, and put minus 2. Again, you will notice we have just completed step number 2, the substitution of this, and we have an x and an x, but the y's have disappeared. You have to make sure that you do not have two different variables once you've completed step 2. Before moving on to step 3. Step 3 says we will now solve. To solve this, we are going to first distribute, so we will take a -4 times a positive 2, which gives us a -8, and bring down that x, so we get -8x, and we'll take a -4 times a -5, which will give us a positive or plus 20. Remember, a negative times a negative gives us a positive. Then we'll just bring down this minus 3x and bring down this -2. Next, we will need to combine like terms. So you see here on the left we have a -3x minus 8x, so those are like terms, resulting in a -11x, and then bring down the plus 20 and the -2. Now we're going to need to get the x again by itself, so we take the constant on the left hand side, which is the positive 20, and we are going to subtract 20 from both sides. These will cancel, giving us a -11x equals, and a -2 minus 20 is a -22. Then the last step, we're going to have to divide by a -11. Those will cancel, giving us x, and divide this side by -11. Please remember that a negative divided by a negative becomes a positive, and 22 divided by 11 is 2. So now we have solved for one of the variables. We have solved for x. We can now go to step 4, which says we are going to use one of our original equations, so either a -3x minus 4y equals a -2, or y plus 5 equals 2x. The second equation looks like it might be a little bit easier for us to use, so I'm going to go ahead and use that one. Now please note, I could use the top equation and it should still work, but we're going to use y plus 5 equals 2x, and we're going to take x equals 2 and substitute it in for x, so that we would now have y plus 5 equals 2, but instead of putting an x there, I'm going to put the number 2 because we just said x equals 2. And then we can solve for y. 2 times 2 will give us 4. Bring down your y plus 5. Then you will subtract 5 from both sides, canceling those out, leaving you with y equals, and 4 minus 5 is a negative 1. Okay? Now please make sure you do not leave your answer like this. Your answer needs to always be in ordered pairs. So we put our x value first, which is 2, and we put our y value next, which is a negative 1. And so here we have our solution, 2, negative 1, which again is the location or the point on the graph where these two equations will intersect. That is the point at which they're going to intersect. Alright, example number 3. We see here in example number 3 we have 9x plus 3y equals 15 and y equals x plus 5. I've done 2 examples for you, so I'm going to give you just a minute. Please pause this and take a moment to work through this and then check your work when you are finished. Alright, so we have found through working through this problem that we have the point 0, 5, which is where the 2 lines are going to intersect. If you had any problems, please look through that, try to see where you might have made your mistake, and if you have any questions, please ask your teacher when you come into class. Alright, please remember to submit the WISC. After you finish this, make sure your notes are complete. If you have any questions, rewind, watch the video again, or come into tutorials and ask for some help. And we'll see you tomorrow. Have a great day.